Hello and welcome back. In this video, I want to continue to look at what's been happening in New Jersey, and it's July 23rd today. Not a lot has changed in New Jersey in the last couple of weeks. We've sort of had, hospitalizations have been dropping off slowly, but then they seem to be bouncing back a little bit. So hospitalizations are sort of sitting around the 800 mark. They were up around 1,000, a month ago. So things are better than they have been, but we might be hitting that local minimum where the infections are beginning to bounce a little bit. It seems like the governor is holding trying to create policy that holds the transmission rate right around the 1, meaning infection should stay fairly constant. You'd like it to be a little below 1, but that seems to be what's going on. So we're in a bit of a holding pattern. A really big question that we do not know the answer to about the future is how long does immunity last, right? So there really isn't data yet saying that immunity has worn out in New Jersey. Okay, so the peak of our infection curve happened on about April 16th in wave 1. And so here we are, so July 16th would be exactly 3 months later. And so April's the 4th month, July is the 7th month, so 3 months later. And we have yet to see a significant number of people being infected more than once. Okay, so with the hundreds of thousands of cases in New Jersey, probably millions of cases, according to our model, we would expect to see people, I guess of the hundreds of thousands who are known to have been infected, we would expect to see some of them coming around for round 2. Some of them, not a lot of them, but some of them being reinfected if immunities were wearing off. So I'm suspicious that immunity lasts at least 3 months. So it's more likely to be something like 4, 5, or 6 months, but maybe it's a year, could even be 2 years. We just don't know. So what we want to do is go back to our model and see what happens depending as we change the time for which we might be immune. So let me switch screens here and pause. Okay, so here we are in MATLAB, and I have the model. We updated to a version 4, which I'll share in the classwork. So you will have this latest model. I've updated it to almost the present. As of this morning, I wasn't quite at, this is a Thursday, so I wasn't quite at week 29. So I put in the number from this morning in the deaths matrix. And then I matched my curve to it. I don't have to keep changing the early A values, but as I add data, I keep changing some of the later A values around where the present is, a couple weeks prior to the present, in order to get the data to match. So you can see we have a pretty good data match. So with that data match, let's see what happens if we stretch this out and look at the overall effect. Okay, so we want to look at to see everything. We want plot choice 6. In order to see things like the infections, we want to go up to a scale of about 20%. And let's actually take the time out to 2 years. So this will be 104 weeks. So this is what our infections will look like. Now, remember before I had talked about the infections basically just dying off, but now we have a repeat in infections. So let me just highlight some of the things that we had changed in the code. Most of you were here when we did this, but some of you may not have been. We added a coefficient D, this is the main thing, that allowed people to go from being, having recovered to once again going back into the susceptible pool. So remember, A was about going from S to E, B takes us from E to I, C takes us from I to R, D takes us from recovered back to being susceptible, all right? Now, what does D equals 1/26 mean? This means that our decay, over 20, we would expect that it would take about 26 weeks for somebody to lose their immunity. That's half of a year. So right now we have this modeled with a 6-month immunity. So that 1/26 of the population who have recovered or are immune would filter back into being susceptible. So it's not that everyone is immune for 26 weeks. There's sort of a constant, we're talking a decay constant of susceptible people back into, I'm sorry, recovered people back into being susceptible, where 126 of them will go back to being susceptible every week. Okay, so that allows people to flow back around again to being susceptible, which is why we end up with this second peak a bit later. Okay, so the first peak was around week 16. Okay, so if 26 weeks later would be around week 42. So you can see right after week 40, we're going to start seeing an uptick in infections because all of these people who had been infected early on a lot of them have returned to the susceptible pool and can get reinfected. Okay, in the period where we are right now, this in between, and you can see the black vertical line, that's where we are now. We have very low infection rates, but that's also probably because our susceptible numbers are way down, okay, according to this model. So if I go up to a scale of 1.1, we can see that the early peak of infections drove the susceptible population way down below 50%, okay? And now the susceptible population is slowly rising again, according to this model. So as more people become susceptible, we might see an uptick in cases. Now, there's another reason we have an uptick in cases. The blue dashed vertical line is when school starts at week 35. I think previously I accidentally called it week 39. And you can see that what I've done up to week 26, the A values are matching the data. But at week 27, I raised the A value a little bit. Maybe we're going to suddenly allow inside dining at a quarter capacity or something like that. So it may go up in week 27, but out here at week 35, I made the A value go up to 2. Because once school starts, it's going to be impossible to keep the A value as low as it was. But it's not going to go up to numbers like 5.5 where we were originally, or numbers like 4, because we'll be doing things like wearing masks. And if someone gets sick, we now have a lot more contact tracing in place. People can get tested quickly. And so it's more likely that we'll keep the number at something like 2. Okay, and notice there are no other A values, so I'm assuming that A stays at 2 forever, starting in week 35. It's possible the governor would start to restrict things again, schools could close again, but this is kind of assuming we open school and just keep it open and keep the A value around 2. Okay, so what you can see is we get a second peak in infections that sort of peaks out around week 50. So that's getting near the end of the year, around Christmas break. We're going to assume the A value stays at 2 even over Christmas break. Maybe more people go to the mall. So who knows, it could go up or down, but we'll just keep it there at 2. But then the infections begin to drop off again. And why? Well, if you look at the blue curve, as we have this second peak in infections, that drives the susceptible population down again. Okay, so at one point, it looks like the susceptible population is down to 30%. And you can see the magenta line is getting near 70%, which would be pretty much considered herd immunity at that point. So 60 or 70%, 70% would be considered having herd immunity. 60% is getting near there. So there's this period of time where we've reached nearly herd immunity. And then as we continue onward, okay, the susceptible population grows again, throughout the spring. But the infections, because it stays relatively low, the infections do continue to die off. And then it looks like there's another third wave that happens, but it's even smaller. Each subsequent wave will be smaller than the one before. It's almost like an oscillating spring where the system is going to hit a steady state. So the susceptible population kind of levels off somewhere below 40%. Looks like about 35% for the susceptible population. In fact, if we want to know what that is, you can type S of, we went to 104 weeks. So at that time, about 33% of the population is susceptible. So 2/3 are immune at that point. or they've died already. I guess that's the other side of things. So that's what could happen in the model. Over time, the susceptible population goes up and down as the infections go through various waves. But as the model reaches more of a steady state, the susceptible population also reaches a steady state. And this would be what living with the virus would look like. We would have a fairly constant infection rate. The susceptible population would stay fairly constant. The immune percentage of the population would stay fairly constant. But remember, people who were immune became susceptible again, but as they cycle through, other people will become immune. So we sort of reach a steady state. In fact, if I take this out to, instead of 104 weeks, let's take it out to 4 years. If we had no improvements in medicine during that time, you can see how it reaches very much a steady state after a while. So that's what, when you hear people saying, well, we just have to live with the virus, eventually that's what living with the virus might look like. Okay, hopefully before 4 years, we would have good vaccines, whereas within 2 years, we may start developing vaccines, but getting them to the population might be tricky. Some of the early vaccines might have bad side effects. So there's all kinds of things that could be going on. But hopefully by 4 years, we would have worked some of that out. So here we are. That's assuming a half year of immunity. Okay. Now what we want to do is look at what happens if we were to change the length of time that people were immune. So I'm going to take this down to 17 weeks, which would mean that people who were immune during the big peak are right about now losing their immunity. Okay, 1/17 of the recovered population would go back into being susceptible. And if we look at that, the graph will change. You can see the second peak was higher. It happened a little bit earlier, and it's definitely higher. Okay, because the susceptibility wore off faster, so this growth in susceptibility happens more quickly. All right, and then the second wave happens and it drops down again. You can see that the susceptible population still kind of levels out at about the same place in the long run. So the long run consequences aren't that different if the immunity is shorter. We would just have the second wave earlier. So you can see where the peak is. It probably happened about 5 weeks earlier. If we compare the overall mortality, it's probably a little bit higher if people stay immune for less time. So let's find out basically the final death count would be about 0.75% over 2 years, remember. So, whereas if we go back to the other model that we had, 26 there, immune for about half a year, we can see the second peak was a little bit lower. And the mortality, if we're immune for longer, we can see the mortality is much better. Okay, so not nearly as many people had to die. That was about 2/3 of what the mortality, well, we can compare the numbers, 0.0058 versus 0.0075. So that would be 58 divided by 75. Okay, so we say, well, it's about 23% of the fewer deaths than we would have had with the shorter period of immunity. Now let's take the immunity out to 52 weeks. So if people are immune for a year, things are better. Okay, you can see that second peak is much smaller and it happens a little bit later, okay? And then it really dies down. And you can see in the steady state, it looks like, we have about 40% of the population remaining susceptible at the end of that. And let's figure out how many people would have, what proportion of people would have died. And then it's down to 0.0038. So that's significantly smaller than it was if there's a half year of immunity. Okay, so we don't have any control over this, but we can watch over time and see when people's immunity begins to break down. Clearly, it's more than 17 weeks. That would be sort of a minimum number to use. We don't know if it goes all the way up to 52 weeks, and it could go as maybe it's 2 years of immunity. If it did, the curve plays out very much like what we saw before, where the susceptible population just drops way off, and then it's going to drop again later during the second wave, and it never really goes back up again. So that's starting to look a lot like it did when we had permanent immunity built in to our model. So we don't know how long people will be immune. For now, we'll just assume a half year of immunity, and then we can compare it to other states like Florida. Okay, so I'll be switching over in the next video. We'll compare what's happening in Florida to what's happening in New Jersey.